Hey guys, and welcome back to Chem Squad Chemistry. This is Mr. Mullins again today. On our last video, I mentioned that we were going to do some neutralization reactions, and then at the end of the video, I just forgot to do them. So we're going to cover that really quick. As I had mentioned before, a neutralization reaction is a type of double replacement reaction, so it's going to look very similar. But neutralization actually tells us what's going to be happening. We're going to be making these things neutral. When we're talking about neutral, we're talking about the pH scale, right? And you know the pH scale goes from like 0 up to 14, with 7 being neutral. You know, acids being down here, bases being up here. We'll learn more about that later in the year. But you know, we're talking about things that are being made neutral. I hope you already know something that is neutral. There's one thing that's always neutral, which is water, which can either be written H2O, sometimes it's written HOH. When you write it as HOH, it really makes sense to see that it's neutral. We know that acids are acids because they start with hydrogen, and we know that bases are bases because they end with OH. So you see that water is the perfect mix of an acid and a base, which is why we call it neutral. So in these problems that we're going to be practicing, we are going to be creating water through a neutralization reaction. So we're going to be taking a base, mixing it with an acid, and creating water, which will have a pH of 7. So it's going to be something very easy like this. We have H2SO4, which you know is an acid because of the H, plus sodium hydroxide, which we know is a base because of the hydroxide. And you can see this looks just like a double replacement problem where we have two compounds. We're going to label our cation and anion, right? And hydrogen is going to be attracted to OH, which is going to make HOH. Remember, that's water. HOH is water. That's how you know this is a neutralization problem, because we're making water from an acid and a base. And this other thing that we're making is going to be Na and SO4. So we have Na with a positive 1 charge and SO4 with a negative 2. So we get Na2SO4. This other thing is considered a salt and water. All neutralization problems are going to make salt and water. Start with an acid and a base and make salt and water. So that's how all of them are going to go. Let's go ahead and do one more neutralization problem. Here is our next neutralization problem. We know that it's neutralization because we have an acid and we also have a base. In this situation, we also see that hydrogen is our cation, fluorine being our anion. So we have those here. Our hydrogen is going to want to bond with the OH. That gives us HOH. Again, that is water. And we are going to have our Na bonding with our F, which we know Na is a positive, and we have F, which is a negative 1, so we get NaF. And here we see our salt again. So again, you're still going to need to balance these equations just like you did a double replacement. These are just specifically called neutralization because the same thing happens every time. An acid plus a base is going to give us water and some type of salt. The salt can be anything. Typically it's something from group 1 and group 7, but not always. But anything from group 1 and group 7 bonded, the alkali metals and the halogens are typically called a salt. So just like one you already know, NaCl, from group 1 and group 6. Group 7. So if there's anything else that you need help with, just let me, Miss Spivey, or Miss Bennett know, and we will help out. Chem Squad out.